Hi students, let's look at the last part of Pythagoras theorem. So basically for this chapter on Pythagoras theorem, there's only two parts, two main concepts. The first main concept is whereby when you have a right angle triangle, the square of the hypotenuse is equals to the sum of the two square of the other two sides. So c square equals to a square plus b square. And this happens when you have a right angle triangle as the main condition. So when you have right angle triangle, these conditions on the right side holds. So for the next part is the converse of Pythagoras theorem. So what does converse means? Converse means the opposite sides. So what does it mean? So whenever we have c square, which is the hypotenuse square, equals to the sum of the square of the remaining two sides of a triangle, we can say that this triangle is a right angle triangle. So it's like the opposite relation also holds. So when we're able to find out that this relation between the sides of the triangle holds, we can say that this is a right angle triangle. So let me tell you how to apply this to the question. So let's look at page 238, exercise 11C on question 4. So in this question, they say that in this figure, AB equals to 12 cm, BC equals to 9 cm, and DC equals to 8 cm, and so on and so forth. And triangle ABC is a right angle equals to 90 degree. So ABC is 90 degrees. So this means that triangle ABC is a right angle triangle. So we are supposed to find X. So using Pythagoras theorem, since we know that triangle ABC is a right angle triangle, we can say that the hypotenuse square, which is X square, equals to 9 square plus 12 square. So to find X, I just take square root of 9 square plus 12 square, which gives me 15 square. So for the next part, it uses the converse of Pythagoras theorem in order to prove whether is this triangle ACD is it right angle triangle, is it a right angle triangle. So to prove that triangle ACD is a right angle triangle, we need to show that AD, which is the hypotenuse square, which is the hypotenuse, this relation must hold whereby the hypotenuse square must be equals to AC square plus CD square. So how do we express our answer? So first step, we need to show that the left hand side, we need to find out what is the value of the left hand side. So AD square, which is 17 square. So what is 17 square equals to? So key in your calculator is 289. So now for right hand side, which is your AC square, which is 15 square, and your CD square will be your 8 square. So this value over here, they must add up to 289 to show that this is a right angle triangle. So if the value is not right, it means that this is not a right angle triangle. So punch the calculator. So this is equals to 289 as well. So since left hand side since AD square, which is your left hand side, equals to AC square plus CD square triangle ACD is a right angle triangle. And you put shown. So the sum of the left hand side must be equal to the sum of the right hand side in order for us to show that this ACD is a right angle triangle. So thank you.